Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about 3D printing houses. So basically a 3D printer that prints homes. So what's the problem? Why the heck you want to do something so complicated? But the reality is, fundamentally speaking, at this point in time, there is a global housing crisis. What does that mean? That simply means every place, including India, America, Pakistan, Africa, everywhere there is a serious lack of homes. Now fundamentally there are many reasons why that is, because we have solved many problems, and the core reason for that is advancement in technology. For example, mobile phone was like just a dream. Now almost everybody has it. Why? Because of mass production. Basically newer technology allowed us to make it cheaper, more efficient, while making it higher quality also. So basically everything became GG. But our construction technology, basically how we are building buildings and how we are making homes, it did not change fundamentally speaking. Only thing is like it's a bit better with more electrical wiring and all that jazz, but nothing fundamentally changed. So we are stuck at exactly the same technology that we were using in 90s, we are using in 1800s or even 1700s, like fundamentally more or less the same. So what does that mean? Well, like if it's so true and tested, what's the side effect? Side effect is slow and expensive. Now expensive part is the primary reason. Like most people can't just afford a house, so that is a very serious limitation. And given that it's a planet-wide crisis, we need a technology to solve this problem. It's not just good to have. No, it's must have kind of technology requirement. Now, another aspect you also have to understand, that anybody who is dealing with large contracts, they would know, is time. Now, time is basically one kind of commodity that you need. Like you can't just, okay, here's $1 trillion make a space mission right now. You can't do that. Like you need time, you need years to make that happen. So same goes with everything, buildings, homes, bridges, things of that nature. So you have to understand the core principle. No amount of money can buy time. Fundamentally, time is not an asset you can buy. So what does that mean? That simply means manual labor that we utilize right now, basically people doing their stuff, it's very slow and it's also dangerous for them. Now fundamentally there are many articles, now I do not know the exact validity of it, but I'm reasonably sure that it's true, is that there are many projects in Noida, in basically every metropolitan on the planet, that they are like they bought the land, they started the project, and poof. So things of that nature happens because it took too much time. And while many people have this idea like government can keep paying for it, government also has expiry date. If for example, let's say this housing project was like, hey, build this housing project in 4 years, they can stretch it to 6 or 8 if they are generous. They can't stretch it to 12 or 13 if it's getting delayed, simply because even central government has a limitation of money. Fundamentally they cannot just go YOLO on it. So time is also an asset. So if we can shrink the time aspect, even if the material cost is exactly the same, it will still become cheaper, simply because time is a asset, so to say. Time is money fundamentally. So what kind of material do we need for this 3D printing house? Now generally whenever you're talking about like building solid, something solid, you think about concrete. Now what is concrete? Concrete is cement plus sand plus gravel. Now it works, it's a fundamentally time tested solid thing, robust, precise, absolute. However, it's not very useful for a basically printer kind of scenario, because in printer you have a what we call extruder, and it has to lay down beads, so to say, or filament path, whatever you want to call it. Now problem is that is normal concrete is very runny. It's like it runs like a water, it's like a gel. It cannot hold its own shape. So you need something that matches two core criteria. Depending on your printer, depending on what kind of climate you are working on, you would want to control these aspects. So what you need is high viscosity and self-supporting. So basically you lay down a bead, it should stand on its own, and then you should have the ability to lay another one on top of it. So you should be able to keep doing like that. So based on that, like based on its load carrying capacity, you have to figure it out, like how long does it take to harden itself. Do you want quick setting concrete? Do you want like slow setting? Do you want a scenario where it's like, dude, it's not gonna set unless we spray it with water? So you have a printer that is like laying down the beads, but once that is done, it lays a worker sprays water, so it starts to harden. So things of that nature happens, like where you figure out how the heck you want to do this. So material has to be changed. It's not just like take normal concrete, done. It has to be fundamentally different. Thankfully there are many options where you have multiple mix and compounds are possible. What does that mean? That simply means people have figured out, hey, what if we make the gravel size much more smaller, and let's say for example reduce the water content. That kind of gets you close to the ballpark. Or maybe replace sand with fly ash. That also gets you closer to the paste kind condition, basically consistency. Or you can do something different. It's like, hey, let's remove basically sand and replace it with fiber, or maybe replace the stone aspect with fibers, different kind of fibers, organic fibers, or like sometimes manufactured fiber, but it gets the job done. So there is a lot of possibility. Like there is a lot of companies that are working on this, and all of them have their different basically mix, so to say, secret sauce, so to say. And on top of that, maybe you are working in a place where you don't have GG amounts of money, where you can experiment with concrete, like how the heck it's gonna set and all that jazz. What can you do then? Well, thankfully, people, the ingenuity that are in display here, it's amazing. So people have already figured out how to use clay, basically soil and water. Soil plus water plus some hay stack. Yes, hay stack, as in like bio fiber, so to say. They have successfully made a structure, and it is solid, stable, much better than the brick house, simply because when you are using a 3D printer, you can use geometry to reinforce things. And when you see a bridge, why don't you see just a solid block of metal? Why do you see the zigzag pattern? That pattern makes it stronger while making it lighter, which also makes it inherently stronger. So same thing can be done with a 3D printed house using similar things like clay and grass. I have provided the video down below and you can check it out. It's amazing. Now, be mindful, it's an early stage of technology, so there is a lot of growing pain, but it's something that, hey, this is a machine, I'm gonna send it to, let's say, one place in Africa, and they can do it. Done. Just figure out how the heck you're gonna power it, let's say solar power, and the material requirement is nominal requirement, so people can actually do this, and they call it zero cost homes. It can be done. Now, if you are in a metropolitan city, you have GG amounts of money, you have concrete options. So fundamentally, lot of option. You are not in a position where it's like, no, only this way to do it. There is a lot of option, and depending on different price point, different requirements, different architecture, you can go YOLO on it. So we have more than enough option at this point in time. Now, how can you actually print it? Well, if you look at human, you will see we have an arm. Now this arm has the ability to be positioned precisely in 3-dimensional space: X, Y, and Z. Basically, let's say in 3D printer, Z is generally like this. So when you take a normal printer, it's a X and Y, and Z dimension is the up dimension. But your hand can do all these things. Hand can do all this. So somebody is like, hey, we already use this hand logic in car manufacturing, and there is a lot of company that make this kind of equipments, even heavy equipments. So why not just buy that? Don't do extra things, just buy that and modify it. And that started to crop up everywhere. Basically, you type 3D printed home company, every other one would be robotic arm design. Now again, arms itself could be different. Some could have like a crane arm, basically. Some could have a JVC kind of arm. Some could have a custom electromagnetical arm that is specifically designed for industrial application like welding and all that just because ABB, there is a company that is doing amazing work with ABB robotics. ABB basically is a very large company. It makes GG amounts of equipment. They're like, you already have the equipment. Let me just replace the end effector. Let's say it would have been a welding machine in another one. Just replace that with basically a extruder. Done. Job done. Now, what does this mean? What this is a very complex system. You have to understand. That's why 3D printers that you buy for desktop 3D printers, they are never come with robotic arm, simply because it would be too goddamn expensive. It's a very complex system. However, it does have the luxury of having a small footprint, because basically when you're thinking about, okay, this is equipment that has to be used anywhere on the planet. You could not be like, you do not have the luxury, okay, like this project is happening here, I have this highway to, carry down my equipment, and I'm gonna do YOLO and all that jazz. Yeah, you don't have that luxury most of the time. So you want to have something that is compact. Basically, I go there, I lay down, done. So this can be done with this kind of technology, robotic arm. Then what if you don't want robotic arm? You want something basically which is kinematic wise much simpler. You can use gantry cranes. Now gantry cranes is a mature technology. At this point in time, you can just go to a company. It's like, I want a gantry crane that has the ability to lift, let's say, lift 50 tons or 60 tons. They're like, to buy this model. And Samsung makes some amazing ones. China has one bonkers one which can lift up to 20,000 tons. So you get the point. Like, crane technology, especially with gantry crane, it's mature enough, and it has the luxury of moving in 3 dimensions. So this is a simple system. However, it does have a side effect. It has to be generally outside the building parameter. It cannot build from inside out. It has to generally, like, this is my build volume, I can only build inside it. There is a limitation with this. Now again, you can stretch it, so you can be like, okay, this, you can easily see that nowadays even with vertical skyscrapers, it's just like there is a build area, it builds it, and then it clamps it on, pushes it up forward, builds another one. It's like a earthworm. It's like tuk 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 going up. So the same can be done with a 3D printer, but principally speaking, you always are inside the build volume, not outside of it. Robotic arm does give you that advantage, does allow it to be much more mobile, but this has the advantage of much more simpler systems. It's like, yeah, if a common person sees this kind of printer, they're like, oh, I understand that. If they see robotic arm, it's like, what the heck is happening? So there is a pros and cons, and like every other company is using this one. Now what we can expect in the future? Well, you have to understand this. Because our homes are precious, important and long lasting structures. These are not like a mobile phone you're gonna throw it away in 2 years. It's a long lasting structure. We need time to test these things out. We need time to figure it out, like absolutely zero. Because many times we don't think about like what amount of engineering went into just making a normal concrete, the amount of engineering figure out, like, you know, builder practices, normal practice, all those things have 100-year plus research on that. And like as in like actual scientific research and old school research where they're like, you know, they tested other things and it did not work out, so they are using it. Same thing will happen with 3D printers. So do expect very long amount of time before it actually becomes tada 3D printer homes. It will take time. So mass adoption will take time. I'm easily expecting 20 to 30 years, and that's if everything goes well. Now, what does the benefit holds? Like benefit is green, basically, especially in impoverished area, they can utilize soil, clay, basically biostocks. What does that mean? That simply means they are not producing carbon dioxide for concrete. That is awesome. That is not only cost effective, it's also green. And efficiency wise, because geometry can be controlled in much more dynamic way, you can have a system where you can literally tell an engineer, hey dude, I need a proper thermal flow, so I do not need, like, you know, very expensive air conditioning unit. You can design that with normal brick and mortar system. Can it be done? Yes, it's just gonna cost you an arm and a leg or a kidney or both. So you get the point. Like we have a lot of luxury, because in 3D printing terms there is a pseudo word going around that complexity is free. Technically it is. You can do bonkers kind of structure. So there's a lot of actual useful potential. It's just not like, oh, it's a luxury thing. No, it has a lot of actual useful potential. And another aspect is we humans want to expand out. We want to go to moon. We want to go to Mars. We have to do this. There is no other way. There is no other way where you can have habitats. The core reason is that habitats will get saturated by radiation very quickly. Like once you have like how you see in low grade sci-fi movies, like they have a habitat. Unless you bury it, it's gonna, over time it's gonna become radioactive. So fundamentally you have to build it out of much more thicker material. You can't carry it, so what the hell are you gonna do? Clay. So tada, there is like NASA is taking this so seriously. They had a like 1/3 scale actual competition. Like there were 20 competitions, basically competitors, and only 2 survived to the final stage, and they had to actually build it, and they had to build it live. It was not like tada, this is built. No, you have to do it in real time. And like NASA judges were there on site to check it, and it was 1/3 scale. So it was not like a toy scale. No, it was like 1/3 scale. And they did this, and 2 companies that successfully reached this stage, they did final testing. Actually they were randomly brought out a bulldozer, like compress it to figure out what kind of compressive strength we are talking about. So this kind of crumbled a bit earlier, and this was much more stable. So design wise is, because you have to understand in Mars specifically, it also has to be pressurized. So there is no outside pressure holding it in. It is like around 15 psi from inside to outside would be like, let's say 0.1 psi. So it's almost like in a vacuum. So we have to figure this thing out. It has to be done for us to become a multi-planetary space. It's not a niche technology. It's not like good to have. No, it's a kind of necessary step, so to say. So this was my presentation on basically 3D printed homes. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.